This is the second and final video for section 7.1. So now we're talking about arctan. And with arctan, we're talking about the same kind of stuff we did with sine and cosine's inverse. So again, we need to restrict the domain of tangent so that tangent is now 1 to 1. So in that case, we're going to be looking between pi over 2 and, negative pi over 2 to pi over 2. So actually, I've got a couple mistakes on here. I'm sorry I didn't catch them sooner. This should be negative pi over 2, and this should be pi over 2. And so you can see that from the graph over here and from what's written on my domain. But also that the range should have open brackets. So we know that just from regular old algebra stuff. So we're restricting the domain of tangent. We're looking from negative pi over 2 to pi over 2. With the inverse of tangent, our domain and range is going to flip just like it did with sine and cosine. So the domain of arctan is now negative infinity to infinity, and the range is going to be negative pi over 2 to pi over 2. Now again, we still need to think backwards with arctan. In this case, though, we're looking only in the first and fourth quadrants. Okay, the domain of tangent, we restricted it to negative pi over 2 to pi over 2. So we're looking in just the first and fourth quadrants. So let's get a start on 3a. So just like we did with the first example for sine and cosine, we need to isolate theta. So in order to do that, we're going to take the inverse of both sides. Right? So the tan inverse and the tan cancel out. So I'm left with theta equals arctan of 1. So now you need to ask yourself, where am I on the unit circle, specifically in the first and fourth quadrants? Where am I that my tangent equals 1? Well, from the all stupid trick crap that we know, we need tangent to be positive, which means it's going to come from the first quadrant. And tangent is 1 at pi over 4. So we have that theta equals pi over 4. And you can check yourself by saying, is tangent of pi over 4 1? Well, yes it is. So we are correct. All right, so now B, we already have the first step done for us. Theta is already isolated. So now we need to think, well, where on the unit circle is tangent root 3? Well, we can see that root 3 is positive, so again, we're looking up here in the first quadrant. But where is tangent root 3? Well, I'm looking at either pi over 3 or pi over 6. And if I start down here at pi over 6, then I have 1/2 and root 3 over 2. So the tangent of pi over 6 is actually 1 over root 3. So in that case, our tangent is the tangent of pi over 3 is root 3. So theta equals pi over 3. If you want to see the work for that, then the sine of pi over 3 is root 3 over 2. Divide that by the cosine, which is 1/2. If you flip that up, you're left with root 3. Right, so the tangent of pi over 3 is root 3. So we're good with this one. So now this last one, we already have the angle measurement. So we need to write C in a way that is not as ugly with this inverse tan. So we are going to get rid of the arctan and isolate y by taking the tangent of both sides. Tangent of pi over 6. So again, my tangent and my arctan cancel out, and I'm left with y equals the tangent of pi over 6. Well, that's something you guys know, right? The tangent of pi over 6, we actually just did over here, is 1 over root 3, or I know we need to rationalize that, so we have root 3 over 3, okay? So y, in this case, y equals root 3 over 3. Right. So now, here is Quizzle question 1. Go ahead and take a shot at A, B, and C. Right. So now we need to talk about the reciprocal functions. So we have secant, cosecant, and cotangent. Up here we have the domain and ranges of all of the inverse functions, but don't forget that the domain and range in this case is the opposite of what the original function was. So if we look at, if we're just looking at cotangent, the domain of cotangent is actually 0 to pi, and the range of cotangent is negative infinity to infinity. And again, I messed up with these brackets up here. Sorry about that. All right, so here's our domains, here's our ranges of our reciprocal functions. But when we actually go to find the inverse of these functions, we have to follow a few steps. So the first thing we need to do is change the function to its reciprocal partner. It's still going to stay the inverse, but we're changing it to its reciprocal partner. So with A, we're changing this cosecant to its reciprocal partner. So the reciprocal of cosecant is sine. It's going to stay the inverse, but now we're going to change the number inside of our trig function to its reciprocal, but we're leaving the sign. So in this case, our sign is positive, so it doesn't matter, but the reciprocal of 2 is 1/2, and that's still equal to theta. So where am I on the unit circle where my y value is 1/2? Well, the sine of pi over 6 equals 1/2, so theta equals pi over 6. Right. Right. So now we're talking about secant. So we're going to switch secant to its reciprocal partner. So we're talking about cosine inverse. We're going to flip root 2 to its reciprocal partner, which is 1 over the square root of 2, or since we need to rationalize it, we're flipping it to root 2 over 2 equals theta. So where am I on the unit circle where my cosine equals root 2 over 2? Well, if I look up here with my domain, excuse me, okay, ignore that, sorry. Where am I on the unit circle that my cosine equals root 2 over 2? Well, I am at pi over 4. So the cosine of pi over 4 equals root 2 over 2. So theta equals, undo. Theta equals pi over 4. Okay. Sorry about the little mix up on that one. All right, last one. Cotangent. Flipping it to its reciprocal partner. So I'm flipping it to tangent, leaving it the inverse. Flipping what's inside here to its reciprocal partner. Well, the reciprocal of 1 is just 1. Equals theta. So where am I on the unit circle where my tangent equals 1? Well, the tangent of pi over 4 equals 1. So theta equals pi over 4. Right. So now here are your last 2 questions. So I want you to think about why the values from pi over 2 to pi and 3 pi over 2 to 0 are not included in the range of arcsecant. So why are the second and fourth quadrants not included. And I want you to determine the exact values of these three inverse trig functions down here, okay? So just follow the same steps we did up here, and you'll be good.